Any questions, anyone? Okay, so when we graph two equations, linear equations, here, let's say here's one. I'm going to call this y1 as they did. And let's say here's another one. If the color is not good, let me know, please. So this is my y2. See, they intersect in this point. So at this point, let's say x equals 1, both y values are the same. Let's say 3. So at 1 comma 3, these two lines intersect. They have to have the same value if they intersect. It is possible that we may have not two straight lines, but maybe we have something like this. So here's another situation. Let's say I have this function. Let's say this is my y1. And let's say I have my y2, this. This is my y2. Look at what happens here. 1, 2, 3. At this x value, both y values are the same. At this x value, both y values are the same. At this x value, both y values are the same. So I'm just going to pick some numbers. So negative 10, 1, and 10. So at negative 10, both values are negative 2. At positive 1, both values are 1. At positive 10, both y values are 7. So here I had only one point of intersection, 1 comma 3. But here I have 3 points of intersection. For negative 10, I have the same y. For positive 1, I have the same y value. For positive 10, I have the same y value. So finally, let's share. See, at negative 3, the values are not the same. No. At negative 2, the values are not the same. No, that's not a point of intersection. At negative 1, the values are not the same. It's not a point of intersection. At 0, it's not the same. They're not the same. At 1, they're not the same. At 2, they're not the same. At 3, they're not the same. So there are no intersections here. So they are not intersecting. The question, however, is, does the graph of y2 pass through the origin? Okay. The origin has the coordinates 0, 0. So when x is 0, if I don't get y0, the graph does not pass through the origin. So here's a graph that passes through the origin. When x is 0, y is 0. The graph passes through the origin. So let's see what we have here. At 0, it's not 0. It's not 0. So does the graph of y2, just y2, pass through the origin? No, because when x is 0, y is not 0. So the answer is no. For 15, do we all understand this? Please say something.
No, that's the one that I had a question about.
No, the previous one. We haven't talked about 15. Is 14 clear?
Yes.
Excellent. Now let's talk about the next one. I just wanted to make sure that 14 is clear. Okay. So this is what we just discussed. The graphs of y1 and y2 intersect at the points, yes or no? At negative 3, the y values are not the same. At negative 3, that x equals negative 3 does not create a point of intersection. What about negative 2? Yes or no?
No.
No. What about negative 1?
No.
What about negative 1?
Yes.
Yes, because y1 is 4 and y2 is 4. So look what we wrote here. For x equals negative 10, y2 and y1 are both the same value. At negative 10, both are the same value. Right here, y2 is negative 2, and y1 is also negative 2. That's why this is a point of intersection. The points are the same. It's the same point, and they have the same value. So this point is negative 1, 4, negative 1, 4. So that is a point of intersection. At 0, is 0, at x equals 0, is this a point of intersection?
No.
No. Is 1, x equals 1, a point of intersection?
No.
What about 2?
Yeah.
Yes. 2 comma 7 is a point of intersection. What about 3?
No.
No. So the first one is negative 1 comma 4. That is a point of intersection. Always, always read the fine print. Type ordered pairs. Use a comma to separate answers as needed. I have to put parentheses, negative 1 comma 4, comma 2 comma 7 in parentheses. So I will write them like this. Negative 1 comma 4 and 2 comma 7. This has to be entered as they asked it, otherwise we get a error.
I got a question.
Yes.
I kind of understand, but why are you using this graph? I don't see that on that graph. That's one you were showing us.
They are not showing you the graph. They are showing you a table. They don't have to show you.
But you were showing us the graph, and you was doing something that's just, you know, you was doing something here. I get it, but I'm trying to understand why did you go here?
Because it's easier to illustrate with a graph and then explain on the table.
Okay.
It was easier for me to show you the points of intersection first and then read them. Once we read them, we have them in the table. But I couldn't just show you the points without showing you the graphs of what I'm trying to explain. So once we know the graphs, now the table is simple to create. But if I give you the table, you can say, what is this? What are you showing me? That's why I gave you examples with graphs, because from the graphs, we create the table.
Yes.
When we are given the function, we create the table and then we present the graph. That's true too. But we don't have the function here. Because I don't have the function, I needed to give you some example before we read from the table. It's a very good question, Bren. Because where's the connection? You are correct. Okay, so this was our example. Let's see number 16. I guess there is no question here. Is there a question on number 16, or 16 is clear?
I think I had a question on 16.
Okay.
I was just a little confused about the part B.
Okay, so I have to enter part. So use the appropriate line graph to determine the percentage of seniors who use marijuana in 1995. So 1995 is here. Marijuana is in red. So I have to read 20%. So in my case, because it will not give me the next step, I think, right?
Yeah.
And okay, so let's see part B. Use the appropriate formula to determine the percentage of seniors who use marijuana. Oh, okay. So M is the marijuana. So we are going to enter in the graphing calculator negative 0.5x. We don't have N. Negative 0.5x, and that's our N. We don't have N. And then they say plus 26, plus 26. And then second and table. And now let's see what they want us to enter. Use appropriate formula to determine the percentage of seniors who, okay, in 1995, now I have to read from the beginning. The graph shows the percentage who used such and such during the 30-day prior to being surveyed. Okay, the data can be described by the following mathematical models. These are the models where N is the number of years after 1980. So we are talking about 95. How many years after 1980 is 1995. That is the number that is n that I have to enter it in the graphing calculator. What's
25 years.
say it again?
25 years.
From 80 to 95.
Oh,
15.
15. So we are going to enter 15 in the graphing calculator. I will press enter. I will go and highlight. Sometimes it's clear now, but sometimes you may want to highlight it because you may have more than one decimal digit, right? So 18.5. So I go back, I enter 18.5 and hope for the best. Thank you. Was this clear?
I actually got lost with the putting in the calculator, to be honest.
Did you enter your function?
Yes, I entered the function.
Did you go to second and table?
Now I am. So put in 15.
Correct, and press enter.
Okay.
Can you do that again, the second and take?
Yes, so let's start from the beginning. First, I have a function. So I will click on y equals. I will enter negative because you start with a negative, you have to use this symbol. In the middle of an expression, you have to use this symbol. But you have to start with this, so it's negative, the tiny negative, not the operational negative. Negative 0.5 x plus 26. Here's your x right here. Then you go to second and table and enter 15 and press enter. Did you get 18.5?
No.
Okay, did you enter it in y equals with negative 0.5 x plus 26? When you go to y equals, do you have negative 0.5 x plus 26?
Oh, I got it. I found it.
And then second and table, and you put 15 and press enter. Did it work?
You typed at the bottom?
Where's the table at? I'm looking for the table. Where's the table button?
Right here at the very end table. Very end.
All right, there you go. Thank you very much. Yes, ma'am. I got it.
So maybe were you able to enter 15 or not?
Mine doesn't let me, but I was able
Okay,
to.
so let's do this. Remember what we did the other day on Monday. Second and table set. Table set is the second one here at the top. Second and table set. Do you see this window?
Yes.
Can you scroll down to independent and move to the right? Highlight ask. Scroll down with these arrows. And when you get to the independent, scroll to the right, highlight ask and press enter.
Okay, done.
Now go to second and table again and punch in 15 and enter. So second and table, the last one.
Okay, I'm done. I did it.
And did you get 18.5?
Yes.
Excellent. So now when we go back and we enter, this is the problem they gave me, but you're probably having a different problem, right? So I got 18.5. Now it's asking me, does the formula underestimate or overestimate the actual? The actual is 20. The formula gave us 18.5. Is this an overestimate or an underestimate of the actual value?
Underestimate?
Yes, it's an underestimate. By how much? In my case, 20 minus 18.5 is 1.5. So I put 1.5 and check answer. Use the appropriate line graph to estimate the percentage of seniors who used alcohol in 1995. So now we are talking about alcohol, we are talking about 1995, and we have to estimate this. This is hard. This is hard because it's not on the grid, right? So at 1995, I would say 53%, but I have no idea. This is a hard one because it's very difficult to check. It says nice work, but I don't know if it's really 53. That was my estimate. Use the appropriate formula again to determine. Okay, but this time I'm going to use the other formula. So I go to y equals, I clear, I have negative 0.8x plus, what was it? Plus 57. And now again, I do the same thing with 15. Second and table, I plug in 15 is 45.
Okay, my thing come error syntax. How do I fix that?
You didn't use the negative, the tiny negative. You have to use the tiny negative when you start with a negative. So remember in the graphing calculator, when you start with a negative, to enter an expression with a negative, you have to start with this negative. So I got 45. I check the answer. And then it says, how does this compare with the estimate from part C? So the estimate was 53. And the answer was 45. The formula appears to underestimate the percentage when compared to the line graph. For the period from 1980 to 2009, I think we have to stop for a little break. I'll give you the break now. Do I have to continue this, or is it clear now? Is the problem clear?
I'm clear with that.
So for the period of between this and this, it says in which way was marijuana used by seniors at a maximum. So here's the maximum right here. That is the maximum in 1980. 1980 was about, difficult to say. I'm going to say again 33, but it may be 32. I'm going to put 32 this time. It took it. Good. So I think let's take a break. Stretch